Hello everyone, we a batch of three students, Abu Faisaliam, Justin Jaikariam, Kritik Rajas, have come up with an innovative idea of combining drone and rover to rover for short range flight. Before getting to problem statement, let me tell you how we came up with this idea. Recently, NASA launched a rover to explore the surface of Mars, which is currently active. A small robotic helicopter named Ingenuity, or also called as Ginny, operated along with the Perseverance rover. It was successfully made first power control flight in the Martian atmosphere that flew for a duration of 39.1 seconds. From these, we got an idea of combining the rover with quadcopter, which is expected to have the nature of both rover and drone. We have initialized this idea to our mentor, Mr. S. Tamilselvan, Assistant Professor of Hindustan Institute of Technology, Aeronautical Engineering Branch. With this guidance, we got the support of Vaisastra Aerospace, Chennai, to make our project into working model. This is our project hybridization of obstacle sensing rover with remotely piloted aerial system, which comes under robotics and drones sector. First of all, what is rover and what is drone? Rovers are the robots used in surface exploration of other planets. These robots are mainly used for identifying biological evidences and samples in other planets. Nowadays, rovers can also be used in detection and rescue in earthquakes and also in other natural calamities. Drones are the flying robots which is mainly used in aerial surveillance. Nowadays, drones are also used in agricultural fields to food delivery. Now, here is our statement of problem. The rover's mission may be get affected when there is a sudden elevation in the surface. Even though rovers can avoid the obstacles and change direction and course, it cannot explore in the frontal area of uphill. Rovers can only capture images by tilting the camera to a certain angle from the surface, but it will be more clear and satisfied when the rovers can capture images by getting closer. For example, consider a man standing in the floor and there is something in the wall. He wants to see it, even though he can see it by tilting his head, but there is a difference between him standing on the floor and seeing it, him going near it and seeing it. Similarly, the rover can only capture the image from the ground, but not the frontal area or the blind spot of uphill or the pits. For this, we are modifying the rover and drone to make it capable for short range flight. By combining the nature of both rover and drone, we can solve the problem using remotely piloted aerial system. Initially, we have made rover and drone separately. These are the components which we use to make rover. Ultrasonic sensor. This sensor is used to determine the distance between the rover and the obstacles by emitting sound waves. When the obstacle distance is closer, which is approximately less than 10 cm, the ultrasonic sensor sends the signal to rover to change its path. Camera module. The camera module is used in the rover to capture images. In this rover, we have used the ESP32 camera module in which it will show the live images over the mobile phone by using Wi-Fi connections. Arduino Uno board. The Arduino Uno is a microcontroller board based on the Atmega 328P. Works on the Arduino code, which is the basic programming codes for the robots. It has 12 digital PWM pins, 6 analog pins, and an USB port and a power jack. Motor driver. The motor driver is used to control the DC motors. In this, L298N motor driver is used to control the set of 2 DC motors simultaneously in any direction. It is a 16-pin driver designed to provide bidirectional drive currents up to 600 mA at voltage 4.5 volt to 36 volts, and we are using jumper cables for connecting purposes. CC3D flight controller. It is an all-in-one stabilization hardware flight controller which runs the OpenPilot firmware. It can fly any airframe from fixed wing to an octocopter, and it features a high-performance 3-axis accelerometer and MEM gyrometer. Brushless motor. It is an electric motor that runs on direct current and does not have mechanical brushes of regular brush motors. It have an overall high speed and torque and produce less noise than the regular brush motors. Electronic speed controller. It is an electronic circuit that controls and regulates the speed of an electric motor. It is responsible for the motor throttle, which is controlled by the remote, transmitter and a receiver, and 2200 mAh drone bed. So, the methodology of this project is: first, study of drone and rover; second, innovation; third, design; fourth, rover model; fifth, drone model; sixth, combining drone and rover; seventh, testing of rover; eighth, calculation of results. First, we studied what is rover and drone, and we had gone through some journals. We came up with an innovative idea of combining drone and rover. We have gathered the components required and we tested those components in Arduino IDE software. Then we made rover and drone by the components stated previously, and then we combined both rover and drone to rover.